Good evening, friends, and welcome to Sleepy Time Tales, a podcast aimed at helping you to get a good night's sleep. This is a podcast where I read old books, sometimes fiction, sometimes non-fiction, in the most boring way I can, to try help you slow your spinning mind enough for you to fall asleep in the most natural way possible. The stresses of life often follow us to bed and keep us company, but I'm here to distract you from them and help you to drift away. Before you do fall asleep, if you find Sleepy Time Tales helpful, and you'd like to support me, to keep it going out to you and thousands of your fellow insomniacs, please consider supporting on the Patreon at patreon.com/sleepytimetales. Or if monthly is a bit much, you can also put a tip in the tip jar. Both of these options are linked in the show notes. Or you can support Sleepy Time Tales by simply spreading the word. If you know someone who's struggling to sleep, just tell them where to find it, and hopefully I can help them. And that's enough of that. We're getting back to learning about the processes of erosion. So snuggle down, close your eyes, breathe deeply and listen closely as I lead you down the path to sleep. We return this week to The Elements of Geology by Harmon Norton. Deflation. In the denudation of an arid region, wind erosion is comparatively ineffective as compared with deflation. Latin de, from, flare, to blow. A term by which is meant the constant removal of waste by the wind, leaving the rocks bare to the continuous attack of the weather. In moist climates, denudation is continually impeded by the mantle of waste and its cover of vegetation, and the land surface can be lowered no faster than the waste is removed by running water. Deep residual soils come to protect all regions of moderate slope, concealing from view the rock structure, and the various forms of the land are due more to the agencies of erosion and transportation than to differences in the resistance of the underlying rocks. But in arid regions the mantle is rapidly removed, even from well-nigh level plains and plateaus, by the sweep of the wind and the wash of occasional rains. The geological structure of these regions of naked rock can be read as far as the eye can see, and it is to this structure that the forms of the land are largely due. In a land mass of horizontal strata, for example, any softer surface rocks wear down to some underlying resistant stratum, and this for a while forms the surface of a level plateau. The edges of the capping layer, together with those of any softer layers beneath it, wear back in steep cliffs, dissected by the valleys of wet weather streams, and often swept bare to the base by the wind. As they are little protected by talus, which commonly is removed about as fast as is formed, these escarpments and the walls of the valleys retreat indefinitely, exposing some hard stratum beneath which forms the floor of a widening terrace. The high plateaus of northern Arizona and southern Utah, north of the Grand Canyon of the Colorado River, are composed of stratified rocks more than 10,000 feet thick and of very gentle inclination northward. From the broad platform in which the canyon has been cut rises a series of gigantic stairs, which are often more than 1,000 feet high and a score or more of miles in breadth. The retreating escarpments, the cliffs of the mesas and buttes which they have left behind as outliers, and the walls of the ravines are carved into noble architectural forms, into cathedrals, pyramids, amphitheaters, towers, arches, colonnades, by the process of weathering aided by deflation. It is thus by the help of the action of the wind that great plateaus and arid regions are dissected, and at last are smoothed away to waterless plains, either composed of naked rock, or strewed with residual gravels, or covered with drifting residual sand. The specific gravity of air is 1/823rd that of water. How does this fact affect the weight of the material which each can carry at the same velocity? if the rainfall should lessen in your own state from 5 to 10 inches a year, what changes would take place in the vegetation of the country, in the soil, in the streams, in the erosion of valleys, in the agencies chiefly at work in denuding the land? In what way can a wind-carved pebble be distinguished from a river-worn pebble, from a glaciated pebble? Chapter 7. The Sea and its Shores. We have already seen that the ocean is the goal at which the waste of the land arrives. The mantle of rock waste, creeping down slopes, is washed to the sea by streams, together with the material which the streams have worn from their beds, and that dissolved by underground waters. In arid regions, the winds sweep waste either into bordering oceans, or into more humid regions where rivers take it up and carry it on to the sea. Glaciers deliver the load of their moraines either directly to the sea, or leave it for streams to transport to the same goal. All deposits made on the land, such as the floodplains of rivers, the silts of lake beds, dune sands, and sheets of glacial drift, mark but pauses in the process which is to bring all the materials of the land, now above sea level, to rest upon the ocean bed. But the sea is also at work along all its shores as an agent of destruction, and we must first take up its work in erosion before we consider how it transports and deposits the waste of the land. Sea erosion. The sea cliff and the rock bench. On many coasts, the land fronts the ocean in a line of cliffs. To the edge of the cliffs there leads down valleys and ridges carved by running water, which, if extended, would meet the water surface some way out from shore. Evidently, they are now abruptly cut short at the present shoreline, because the land has been cut back. Along the foot of the cliff lies a gently shelving bench of rock, more or less thickly veneered with sand and shingle. At low tide its inner margin is laid bare, but at high tide it is covered wholly, and the sea washes the base of the cliffs. A notch, of which the sea cliff and the rock bench are the two sides, has been cut along the shore. Waves. The position of the rock bench, with its inner margin slightly above low tide, shows that it has been cut by some agent, which acts like a horizontal saw set at about sea level. This agent is clearly the surface agitation of the water. It is the wind-raised wave. As a wave comes up the shelving bench, the crest topples forward, and the wave breaks, striking a blow whose force is measured by the momentum of all its tons of falling water. On the coast of Scotland, the force of the blow, struck by the waves of the heaviest storms, has sometimes exceeded 3 tons to the square foot. But even a calm sea constantly chafes at the shore. It heaves in gentle undulations known as the groundswell, the result of storms perhaps 1,000 miles distant, and breaks on the shore in surf. The blows of the waves have not struck with clear water only, else they would have little effect on cliffs of solid rock. Storm waves arm themselves with the sand and gravel, the cobbles, and even the large boulders which lie at the base of the cliff, and beat against it with these hammers of stone. Where a precipice descends sheer into deep water, waves smash up and down the face of the rocks, but cannot break and strike effective blows. They therefore erode but little, until the talus fallen from the cliff is gradually built up beneath the sea to the level at which the waves drag bottom upon it and break. Compare the ways in which different agents abrade. The wind lightly brushes sand and dust over exposed surfaces of rock. Running water sweeps fragments of various sizes along its channels, holding them with a loose hand. Glacial ice grinds the stones of its ground moraine against the underlying rock with the pressure of its enormous weight. The wave hurls fragments of rock against the sea cliff, bruising and battering it by the blow. It also rasps the bench as it drags sand and gravel to and fro upon it. The weathering of sea cliffs. The sea cliff furnishes the weapons for its own destruction. They are broken from it not only by the wave, but also by the weather. Indeed, the sea cliff weathers more rapidly, as a rule, than do rock ledges inland. It is abundantly wet with spray. Along its base, the groundwater of the neighboring land finds its natural outlet in springs, which undermine it. Moreover, it is unprotected by any shield of talus. Fragments of rock as they fall from its face are battered to pieces by the waves and swept out to sea. The cliff is thus left exposed to the attack of the weather, and its retreat would be comparatively rapid for this reason alone. Sea cliffs seldom overhang, but commonly, as in figure 134, slope seaward, showing that the upper portion has retreated at a more rapid rate than has the base. Which do you infer is on the whole the more destructive agent, weathering or the wave? Sea caves. The wave does not merely batter the face of the cliff. Like a skillful quarryman, it inserts wedges in all natural fissures, such as joints, and uses explosive forces. As a wave flaps against a crevice, it compresses the air within with a sudden stroke. As it falls back, the air suddenly expands. On lighthouses, heavily barred doors have been burst outward by the explosive force of the air within, as it was released from the pressure when a partial vacuum was formed by the refluence of the wave. Where a crevice is filled with water, the entire force of the blow of the wave is transmitted by hydraulic pressure to the sides of the fissure. Thus, storm waves little by little pry and suck the rock loose, and in this way, and by the blows which they strike with the stones of the beach, they carry out about a joint, or wherever the rock may be weak, a recess known as a sea cave, provided that the rock above is coherent enough to form a roof. Otherwise, an open chasm results. Blowholes and sea arches. As a sea cave is drilled back into the rock, it may encounter a joint or crevice open to the surface by percolating water. The shock of the wave soon enlarges this to a blowhole, which one may find on the breezy upland, perhaps 100 yards and more back from the cliff's edge. In quiet weather, the blowhole is a deep well. In storm, it plays a fountain as the waves drive through the long tunnel below and spout their spray high in air in successive jets. As the roof of the cave thus breaks down in the rear, there may remain in front for a while a sea arch, similar to the natural bridges of land caverns. Stacks and wave-cut islands. As the sea drives its tunnels and open drifts into the cliff, it breaks through behind the intervening portions and leaves them isolated as stacks, much as monuments are detached from inland escarpments by the weather. And as the sea cliff retreats, those remnant masses may be left behind as rocky islets. Thus the rock bench is often set with stacks, islets in all stages of destruction, and sunken reefs, all wrecks of the land testifying to its retreat before the incessant attack of the waves. Coves. Where zones of soft or closely jointed rock outcrop along a shore, where minor watercourses connect down to the sea and aid in erosion, the store is worn back in curved reentrants called coves, while the more resistant rocks on either hand are left projecting as headlands. After coves are cut back a short distance by the waves, the headlands come to protect them, as with breakwaters, and prevent their indefinite retreat. The store takes a curve of equilibrium, along which the hard rock of the exposed headland and the weak rock of the protected cove wear back at an equal rate. Rate of recession. The rate at which a shore recedes depends on several factors. In soft or incoherent rocks exposed to violent storms, the retreat is so rapid as to be easily measured. The coast of Yorkshire, England, whose cliffs are cut in glacial drift, loses 7 feet a year on the average. And since the Norman conquest, a strip a mile wide with farmsteads and villages and historic seaports, has been devoured by the sea. The sandy south shore of Martha's Vineyard weighs back 3 feet a year, but hard rock retreats so slowly that the recession has seldom been measured by the records of history. Shore drift. Boulder and pebble beaches. About as fast as formed, the waste of the sea cliff is swept both along the shore and out to sea. The road of waste along shore is the beach. We may also define the beach as the exposed edge of the sheet of sediment formed by the carriage of land waste out to sea. At the foot of sea cliffs, where the waves are pounding hardest, one commonly finds the rock bench strewn with its inner margin, with large stones dislodged by the waves and by the weather, and somewhat worn on their corners and edges. From this boulder beach, the smaller fragments of waste from the cliff, and the fragments into which the boulders are at last broken, drift onto more sheltered places, and there accumulate in a pebble beach, made of pebbles well rounded by the wear which they have suffered. Such beaches form a mill whose raw material is constantly supplied by the cliff. The breakers of storm set it in motion to a depth of several feet, grinding the pebbles together with a clatter to be heard above the roar of the surf. In such a rock crusher, the life of a pebble is short. Where ships have stranded on our Atlantic coast, with cargoes of hard-burned brick or of coal, a year of time and a drift of 5 miles along the shore have proved enough to wear brick and coal to powder. At no great distance from their source, therefore, pebble beaches give place to beaches of sand, which occupy the more sheltered reaches of the shore. Sand beaches. The angular sand grains of various minerals into which pebbles are broken by the waves are ground together under the beating surf and rounded, and those of the softer minerals are crushed to powder. The process, however, is a slow one, and if we study these sand grains under a lens, we may be surprised to see that, though their corners and edges have been blunted, they are yet far from the spherical form of the pebbles from which they were derived. The grains are small, and in water they have lost about half their weight in air. The blows which they strike one another are therefore weak. Besides, each grain of sand of the wet beach is protected by a cushion of water from the blows of its neighbors. The shape and size of these grains and the relative proportion of grains of the softer minerals which still remain give a rough measure of the distance in space and time which they have traveled from their source. The sand of many beaches derived from the rocks of adjacent cliffs, or brought in by torrential streams from neighboring highlands, is dark with grains of a number of minerals softer than quartz. The white sand of other beaches, as those of the east coast of Florida, is almost wholly composed of quartz grains, for in its long travel down the Atlantic coast, the weaker minerals have been worn to powder, and the hardest alone survive. How shore drift migrates. It is under the action of waves and currents that shore drift migrates slowly along a coast. Where waves strike a coast obliquely, they drive the waste before them, little by little, along the shore. Thus, on a north-south coast, where the predominant storms are from the northeast, there will be a migration of shore drift southwards. All shores are swept also by currents produced by winds and tides. These are usually far too gentle to transport of themselves the coarse materials of which the beaches are made. But while the wave stirs the grains of sand and gravel, and for a moment lifts them from the bottom, the current carries them a step forward on their way. The current cannot lift, and the wave cannot carry, but together to transport the waste along the shore. The road of shore drift is therefore the zone of the breaking waves. The Bayhead Beach. As the waste derived from the wear of waves and that brought in by streams is trailed along a coast, it assumes, under varying conditions, a number of distinct forms. When swept into the head of a sheltered bay, it constitutes the bayhead beach. By the highest storm waves, the beach is often built higher than the ground immediately behind it, and forms a dam, enclosing a shallow pond or marsh. The bay bar. As the stream of shore drift reaches the mouth of a bay of some size, it often occurs that, instead of turning in, it sets directly across toward the opposite headland. The waste is carried out from shore into the deeper waters of the bay mouth, where it is no longer supported by the breaking waves and sinks to the bottom. The dump is gradually built to the surface as a stubby spur, pointing across the bay, and as it reaches the zone of wave action, current and wave can now combine to carry shore drift along it, depositing their load continually at the point of the spur. An embankment is thus constructed in much the same manner as a railway fall, which, while it is building, serves as a roadway along which the dirt from an adjacent cut is carted to be dumped at the end. When the embankment is completed, it bridges the bay with a highway, along which shore drift now moves without interruption and becomes a bay bar. Incomplete bay bars. Under certain conditions, the sea cannot carry out its intention to bridge a bay. Rivers discharging in bays demand open way to the ocean. Strong tidal currents also are able to keep open channels scoured by the ebb and flow. In such cases, the most that land waste can do is build splits and shoals, narrowing and shoaling the channel as much as possible. Incomplete bay bars sometimes have their points recurved by currents setting at right angles to the stream of shore drift, and are then classified as hooks. Sand reefs. On low coasts where shallow water extends some distance out, the highway of shore drift lies along a low, narrow ridge, termed the sand reef, separated from the land by a narrow stretch of shallow water called the lagoon. At intervals, the reef is held open by inlets, gaps through which the tide flows and ebbs, and by which the water of streams finds its way to the sea. No finer example of this kind of shoreline is to be found in the world than the coast of Texas. From near the mouth of the Rio Grande, a continuous sand reef draws its even curve for 100 miles to Corpus Christi Pass, and the reefs are but seldom interrupted by inlets as far as north as Galveston Harbor. On this coast, the tides are variable and exceptionally weak, being less than 1 foot in height, while the amount of waste swept along the shore is large. The lagoon is extremely shallow, and much of it is a mudflat, too shoal for even small boats. On the coast of New Jersey, strong tides are able to keep open inlets at intervals of from 2 to 20 miles, in spite of a heavy alongshore drift. Sand reefs are formed where the water is so shallow near shore that storm waves cannot run in it, and therefore break some distance out from land. Where storm waves first drag bottom, they erode and deepen the sea floor, and sweep in sediment as far as the line where they break. Here, where they lose their force, they drop their load and beat up the ridge, which is known as the sand reef when it reaches the surface. Shores of elevation and depression. Our studies have already brought to our notice 2 distinct forms of strand lines. One the high rocky coast cut back to the cliffs by the attack of the waves, and the other the low sandy coast where the waves break usually upon the sand reef. To understand the origin of these 2 types, we must know that the meeting place of sea and land is determined primarily by movements of the Earth's crust. Where a coastland emerges, the shoreline moves seaward. Where it is being submerged, the shoreline advances on the land. Shores of elevation. The retreat of the sea, either because of a local uplift of the land or for any other reason, such as the lowering of any portion of ocean bottom, lays bare the inner margin of the sea floor. Where the sea floor has long received the waste of the land, it has been built up to a smooth subaqueous plain, gently shelving from the land. Since the new shoreline is drawn across this even surface, it is simple and regular, and is bordered on the one side by shallow water, gradually deepening seaward, and on the other by low land, composed of material which has not yet thoroughly consolidated to firm rock. A sand reef is soon beaten up by the waves, and for some time conditions will favor its growth. The loss of sand driven into the lagoon beyond, and of that ground to powder by the surf and carried out to sea, is more than made up by the stream of alongshore drift, and especially by the drag of sediments to the reef by the waves, as they deepen the sea floor on its seaward side. Meanwhile, the lagoon gradually fills with waste from the reef and from the land. It is invaded by various grasses and reeds which have learnt to grow in salt and brackish water. The marsh, laid bare only at low tide, is built above high tide by wind drift and vegetable deposits, and becomes a meadow, soldering the sand reef to the mainland. While the lagoon has been filling, the waves have been so deepening the sea floor off the sand reef that at last they are able to attack it vigorously. They now wear it back, and driving the shoreline across the lagoon or meadow, cut a line of low cliffs on the mainland. Such a shore is that of Gascony in southwestern France, a low, straight, sandy shore, bordered by dunes and unprotected by reefs from the attacks of the waves of the Bay of Biscay. We may say then that on the shores of elevation, the presence of sand reefs and lagoons indicate a stage of youth, while the absence of these features and the vigorous and unimpeded attack by the sea upon the mainland indicate the stage of maturity. Where much waste is brought in by rivers, the maturity of such a coast may be long delayed. The waste from the land keeps the sea shallow offshore and constantly renews the sand reef. The energy of the waves is consumed in handling shore drift, and no energy is left for an effective attack upon the land. Indeed, with an excessive amount of waste brought down by streams, the land may be built out and encroach temporarily upon the sea, and not until long denudation has lowered the land, and thus decreased the amount of waste from it, may the waves be able to cut through the sand reef, and thus the coast reach maturity. Shores of depression. Where a coastal region is undergoing submergence, the shoreline moves landward. The horizontal plane of the sea now intersects an old land surface, roughened by subaerial denudation. The shoreline is irregular and indented in proportion to the relief of the land and the amount of the submergence which the land has suffered. It follows up partially submerged valleys, forming bays and bends around the divides, leaving them to project as promontories and peninsulas. The outlines of shores of depression are as varied as are the forms of the land partially submerged. We give a few typical illustrations. The characteristics of the coast of Maine are due chiefly to the fact that a mountain region of hard rocks, once worn to peneplain, and after a subsequent elevation deeply dissected by north-south valleys, has subsided. The depression amounting on its southern margin to as much as 600 feet below sea level. Drowned valleys penetrate the land in long, narrow bays, and rugged divides project in long, narrow land arms, prolonged seaward by islands, representing the high portions of their extremities. Of this exceedingly ragged shore, there are said to be 2,000 miles from the New Brunswick boundary, as far west as Portland, a straight-line distance of but 200 miles. Since the time of its greatest depression, the land is known to have risen some 300 feet, for the bays have been shortened, and the waste with which their floors were strewn is now in part laid bare as clay plains above the bay heads, and in narrow selvages about the peninsulas and islands. The coast of Dalmatia on the Adriatic Sea is characterized by long land arms and chains of long, narrow islands, all parallel to the trend of the coast. A region of parallel mountain ranges has been depressed, and the longitudinal valleys which lie between them are occupied by arms of the sea. Chesapeake Bay is a branching bay due to the depression of an ancient coastal plain, which after having emerged from the sea, was channeled with broad shallow valleys. The sea has invaded the valley of the trunk stream and those of its tributaries, forming a shallow bay whose many branches are all directed towards its axis. Hudson Bay and the north, the Baltic and the Yellow Seas, are examples where the sinking of the land has brought the sea in over low plains of large extent, thus deeply indenting the continental outline. The rise of a few hundred feet would restore these submerged plains to the land. The cycle of shores of depression. In its infantile stage, the outline of a shore of depression depends almost wholly on the previous relief of the land, and but little on erosion by the sea. Sea cliffs and narrow benches appear where headlands and outlying islands have been nipped by the waves. As yet, little shore waste has been formed. The coast of Maine is an example of this stage. In early youth, all promontories have been strongly cliffed, and under a vigorous attack of the sea, the shore of open bays may be cut back also. Sea stacks and rocky islets, caves and coves, make the shore minutely ragged. The irregularity of the coast, due to depression, is for a while increased by differential wave wear on harder and softer rocks. The rock bench is still narrow. Shore waste, though being produced in large amounts, is for the most part swept into deeper water and carried out of sight. Examples of this stage are the east coast of Scotland and the California coast near San Francisco. Later youth is characterized by large accumulation of shore waste. The rock bench has been cut back so that it now furnishes a good roadway for shore drift. The stream of alongshore drift grows larger and larger, filling the heads of the larger bays with beaches, building spits and hooks, and tying islands with sandbars to the mainland. It bridges the larger bays with bay bars, while their length is being reduced, as their enclosing promontories are cut back by the waves. Thus there comes to be a straight, continuous and easy road, no longer interrupted by headlands and bays, for the transportation of waste along shore. The Baltic coast of Germany is in this stage. All this while, streams have been busy filling with delta deposits the bays into which they empty. By these steps, a coast gradually advances to maturity, the stage when the irregularities due to depression have been effaced, when outlying islands formed by subsidence have been planed away, and when the shoreline has been driven back behind the former bay heads. The sea now attacks the land most effectively along a continuous and fairly straight line of cliffs. Although the first effect of wave wear was to increase the irregularities of the shore, it sooner or later rectifies it, making it simple and smooth. Northwestern France may be cited as an upland plain, dissected and depressed, whose coast has reached maturity. In the old age of coasts, the rock bench is cut back so far that the waves can no longer exert their full effect upon the shore. Their energy is dissipated in moving shore drift hither and thither, and in abrading the bench when they drag bottom upon it. Little by little the bench is deepened by tidal currents and the drag of waves. But this process is so slow that meanwhile the sea cliffs melt down under the weather, and the bench becomes a broad shoal, where waves and tides gradually work over the waste from the land to greater fineness and sweep it out to sea. Plains of marine abrasion. While subaerial denudation reduces the land to base level, the sea is sawing its edges to wave base, i.e. the lowest limit of the wave's effective wear. The widened rock bench forms, when uplifted, a plain of marine abrasion, which, like the peneplain bevels across strata, regardless of their various inclinations, have various degrees of hardness. Compared with subaerial denudation, marine abrasion is a comparatively feeble agent. At the rate of 5 feet per century, a higher rate than one obtains on the youthful rocky coast of Britain, It would require more than 10 million years to pare a strip 100 miles wide from the margin of a continent, a time sufficient, at the rate at which the Mississippi Valley is now being worn away, for subaerial denudation to lower the lands of the globe to the level of the sea. Slow submergence favors the cutting of a wide rock bench. The water continually deepens upon the bench. Storm waves can therefore always ride in to the base of the cliffs and attack them with full force. Shore waste cannot impede the onset of the waves, for it is continually washed out in deeper water below wave base. Basal conglomerates. As the sea marches across the land during a slow submergence, the platform is covered with sheets of sea-laid sediments. Lowest of these is a conglomerate, the boulder and pebble beach, whitened indefinitely by the retreat of the cliffs at whose base it was formed, and preserved by the finer deposits laid upon it in the constantly deepening water as the land subsides. Such basal conglomerates are not uncommon among the ancient rocks of the land, and we may know them by their rounded pebbles and larger stones, composed of the same rock as that of the abraded and even surface on which they lie. And that's the end of the chapter, so I think that's where I'm going to call it. As always, if you'd like to pick up where I'm leaving off, you can find the original on Project Gutenberg at the link in the show notes. Thanks again for joining me on this episode of Sleepy Time Tales, the podcast designed around a bedtime story to help you get a restful night. New episodes will be released every Sunday night to give you something fresh to help you rest in a new week. But make sure to follow or subscribe in whatever service you use so that you get new episodes whenever they come out. Good night, and sweet dreams.